is exactly as wide as the 1,428-foot skyscraper next to it. That 800-ton steel weight is swinging right now because the wind is trying to snap this tower. They deliberately left entire floors completely empty, just so the wind can blast straight through. Look straight down. There is nothing but a terrifying drop to the Manhattan pavement below. 200 steel anchors are drilled into bedrock. They don't hold it up, they pull it down. Everyone else gets a clean sight. They get an immovable 90-year-old landmark in the way. The only buildable land sits in a 57-foot strip. That strip becomes the world's thinnest skyscraper. 57th Street is a wind tunnel between two avenues. Steinway Tower sits in the barrel.
Anchors hold it down, shear walls hold it up.
The shovel hits the ground, 12 inches away, a fragile 90-year-old landmark. This is the danger. Under every building in Midtown Manhattan, solid bedrock. The drill is fighting through 30 feet of it. They demolish everything to within 1 foot of that limestone facade. 1 foot, not one more. The new caissons thread between 90-year-old footings. Old and new foundations locked together, permanently. The excavator swings in a 57-foot site with a 90-year-old landmark 12 inches from its bucket. The drill goes 100 feet into solid Manhattan schist. That is 10 stories below the street. That rebar cage is 100 feet long. They lower it into the ground whole, then pour concrete.
Every caisson here carries the load of 20 normal ones. The site is too narrow.
30 meters of steel tendon bonded to rock with epoxy. That anchor is now Manhattan. Seal the fracture with pressurized grout. Let it cure. Re-drill through the sealed rock. Start again.
The building tries to lift. The rock says no. That is the entire system.
36 inches thick, 57 feet wide, 1,428 feet tall. The thinnest shear wall ever at this height. 14,000 pounds per square inch concrete, 4 times stronger than normal. The only mix strong enough for a 57-foot skyscraper. 1 floor every 5 days. The formwork climbs itself. The concrete sets. The wall grows.
36 inches at the bottom, 16 at the top. Wind moment is biggest at the base.
14,000 pounds per square inch concrete placed in 12-inch lifts. Internal vibrator every 18 inches. No voids allowed. None. The formwork is cracking under 14,000 pounds per square inch fresh concrete. If that panel blows, the pour stops forever. Emergence, the form holds. The pour resumes from exactly where it stopped. The concrete gets weaker as the building rises, because the wind forces do too. Every floor calculated.
This outrigger connects both shear walls. The building now acts 180 feet wide instead of 57.
The piano showroom is open above. Below it, micropile rigs are working. Nobody upstairs hears anything. Walk 1 block north and this 1,000-foot tower disappears. It is so thin it hides behind buildings. 0.8-inch lean. Crisis over. Here is the crazy part. 2 entire floors are left completely open. Wind passes through. April 2019. The concrete tops out at floor 85. A 57-foot blade now visible from New Jersey. 1.1 inches of deviation over 435 meters. On a 57-foot wide building. That is the limit of precision.
Floor 36, 14,000 psi, 4 meters deep. 1 shot. You cannot fix an outrigger wall twice.
Truss is spinning in the wind above Manhattan. 4 ironworkers catch it by hand. Flatbed trucks deliver massive steel sections at 3 a.m. Because That embed plate was cast 2 years ago. The outrigger bolts onto it today. Perfect fit. The bolt holes do not align. The embed shifted 0.6 inches 2 years ago. No going back. Slotted holes take the 0.6-inch offset. Torque to 880 foot-pounds. Accepted. It becomes permanent. The spire is an aircraft navigation reference. The FAA requires it at this exact height and position. Sub-zero temperatures at 1,200 feet. Ironworkers bolt spire sections by hand. Welcome to Billionaire's Row. An 800-ton steel box inside the top of a 57-foot tower. Ready to swing. 26 custom terracotta shapes. 6 color variations. Every single panel custom-fired in Germany. For New York. Every other super tall on this street is glass. Shop chooses terracotta and bronze, on purpose. The clay goes in gray. The kiln fires at 1,100 degrees Celsius. The terracotta comes out golden. Steel clips to aluminum rails to the shear wall. That terracotta panel hangs from nothing free. 500 sample panels each. 0.5 millimeters tolerance. Made only for this building. No scaffolding on a 57-foot Manhattan site. Workers hang terracotta from the building's own cleaning track.
Quarter-turn lock. That panel is now permanently attached to...
The setbacks make the building disappear into the sky. Look up. Watch it dissolve. The bronze panels between the terracotta are hand... The north face is perfectly straight. No setbacks. No steps. One unbroken plane from street to sky. The corners are three-dimensional curved terracotta, not a mitre cut, a curve, designed and fired individually. Galvanic corrosion at floor 45. Bronze meets aluminium. Two dissimilar metals reacting. The connection is failing. Neoprene washer between every bronze and aluminium contact. Breaks the galvanic circuit. Corrosion stops. Floor-to-ceiling glass, north and south. Central Park one side, Manhattan the other. 57 feet wide.
Shadow creates the illusion.
The terracotta skin wraps the concrete, but sealing the massive glass windows creates a deadly new problem. A door just ripped from a worker's hands on floor 40. The building is a chimney. 100 pascals of air pressure. Every door above floor 60 is rated for half that. 120 pascal rated closers. Lobby pressurization system. The doors open with one hand again. Problem solved. A 500-pound glass panel just became a deadly sail at 700 feet. 3 men fight it. Installation is dangerous every afternoon. Only between 6 a.m. and 9 a.m. Meteorologist confirms the window, then the glass goes up. No exceptions. The pipe at floor 70 just exploded. Pumping water 700 feet high destroys standard pipe. 300 psi at the pump. Standard pipe is rated for 6 pressure zones. Booster pump every 14 floors. The pipes survive. The elevator rail has a 20 feet per second. 12-millimeter bow, 3,000 pounds of impact. The car is about to derail. Spring-loaded guides absorb 25 millimeters of rail deviation. Active monitoring catches the next one before it matters.
Feel this bow. In a swaying building, the elevator rails must flex constantly. Rigid ones break, always.
The crane that built this building is now trapped on the roof. No way down. Traditional crane jumping needs more building width. This building is 57 feet wide. The crane is stuck. 57th Street reopens. The roof is finally clear. That water is a battering ram, a 75-foot wave machine on floor 17 of a skyscraper. If the pool and the building resonate together, the water destroys the floor beneath. Simple physics. The pool's 6.8 seconds slosh is too close to the building's 7.5 seconds sway. 3-foot standing waves form. Perforated steel baffle cuts the wave from 3 feet to 4 inches. The floor survives 800 feet above 57th Street. 2 workers are reaching for it. The bathtub is longer than the elevator. The only way in, an open panel at 800 feet. 800 feet of exterior hoist. 2 workers guiding 2 tons through an open panel. In wind. The dome comes off, stripped beneath. The lobby floor is base isolated. Both buildings move independently in a storm. The floor stays flat. 12 tons of concrete cantilevering 6 feet over 57th Street. 4 post-tensioned rods holding it up.
I am on 12 tons of cantilevered concrete, 900 feet below 57th Street. 4 rods hold.
The pool water line aligns with the Central Park canopy. They surveyed that to the centimeter, deliberately. 5 milligrams of lateral acceleration at 20 feet per second. Smoother than a hospital elevator. Commissioned. The building moves 30 inches at the top. The damper absorbs 12 of them. Right now. January 2021, 78 miles per hour gusts. The building swings 8 inches at floor 75, and the damper swings back. The anchors are in tension. 4,000 kips of wind trying to lift this building off bedrock. Some wind speeds make this building vibrate like a tuning fork. The damper matches that frequency.